Welcome back to math. Today you're going to need to grab lesson 3.3 from your supplies bag. You also need to go and find the crayons that we gave you. And you're going to need a pencil and a lined piece of paper. You can use the one from yesterday's assignment if you would like. When you have those things, come back. Until then, pause the video. Welcome back. Here we go. Today's lesson, we're going to use area model and partial quotient, or partial products. How can you use area models and partial products to multiply two-digit numbers? If you can answer that question by the end of this assignment, then you have learned what you needed to learn. Here we go. Today we will start with colored pencils, or in our case, crayons. How can you use a model to break apart factors and make them easier to multiply? Outline a rectangle on the grid to model 13 times 18. So right now we're going to put this on the grid. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's make sure I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. All right. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, let me try that again. Sometimes you have to be more careful with your counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So here is my model. Can you see it? All right. Now go ahead and draw yours. If you need to pause, because I'm going too fast, go ahead and pause and come back when yours is done. So I drew my model, and it says break apart the model into smaller rectangles to show factors broken into tens and ones. Label and shade the smaller rectangle. Use the colors below. So we're going to write 10 plus 8 and 10 plus 3. If we use the colors it says, the first rectangle is going to be blue. So go ahead and color yours. I'm going to color mine. How's your coloring going? I'm almost done. Okay, so I've colored in 10 times 10 because 10 and 10. So now over here, this is 8 times 10 because this side is 8 and this side is 10. And it says to color that one green. So go ahead and color that one green. I always like math when there's coloring involved. I don't know why. How we doing? All your blocks colored in? Okay. Putting that crayon away because I don't like to lose my crayons. The next one is orange. So 3 times 10. So here's my 3 and here's my 10. So this one is orange. And this is just all set up so I can help you learn this a little bit better. So color it orange. And then the last one is purple or pink. And it's 3 times 8. So 8 and 3. Okay. Okay. So now you should have a block that looks similar to this. Now it wants us to multiply these different colored areas. So basically what we've done is we've taken 18 and made it 10 plus 8, and we've taken 10 plus 3 for 13. So 10 times 10 is 100. 8 times 10 is 80. 3 times 10 is 30. And then 3 times 8, 24. Now, let's add them. 100 plus 80 plus 30 plus 24. So 100 plus, if I add 80 and 30, that's 110. So 100 plus 110 equals 210 plus 24, 234. Now it's time to go and do the next problem. Draw a model and break apart the whole model to show factors different from those shown in the first label. Label and shade the 4 smaller rectangles and find the product. Record the sum of the partial product to represent the product of the whole number. Now you can see it's already done on my paper, but we're going to go back and we're going to redo it. So go ahead and grab yourself some crayons. I'm going to go grab mine. I decided to use the same colors, so I'm going to do blue, green, pink, and orange again. Now I've got to decide how I'm going to break this up. So let's think. 18. The first 2 numbers that I think of when I think of numbers that add 18 are 9 and 9. 13. Once again, I think of 9 and 4. So let's try that out. First, I'm going to draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is also 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Then I can use those big, bold lines again to help me divide my rectangle. Ready? I'm going to do the first one blue. And that will be 9 times 9. I'm going to do the next one green. And guess what? It's also 9 times 9. So if I know what 9 times 9 is, I just need to write that twice now. Go ahead and finish coloring. I'm going to do my next one orange, which is 4 times 9. And my last one, I'm going to do pink, which is also 4 times 9. So now it's time to do some multiplication. Put my crayons away real quick. Don't want to lose them. Here we go. 9 times 9 is 81. 9 times 9 is 81. 9, that's this row right here, times 4 is 36. 9 times 4 is 36. Then all you have to do is add those all up. Well, that equals 2, that's 162. Add 36. Oh man, I don't know about you, but this one I can't do in my head so easily. So I'm going to take my paper from yesterday's math and I'm going to write 81, 81, 36, 36, and not try and do it in my head. Because when I do it in my head, I tend to make mistakes. So there's 12, 13, 14, write the 4, regroup the 10. And then there's 16, 17, 18, 19, 20, 21, 22, 23. So I end up with 234. 234. Okay, you guys, I'm going to turn the page. I want you to do the same. And we're going to answer some questions about this math. So let me fix my paper. Sorry, guys. Joys of doing this with a little camera. Don't have a whole lot of room. There we go. So we're going to draw some conclusions about what we just did on that first page. So it says, explain how you found the total number of squares in the whole model. Okay, well, I broke apart my whole model. So that would be the big block array we made, whole model, into 4 smaller rectangles. And then what did I do with those rectangles? Then I multiplied them and added their products together. Period. Compare the two models and their products. What can you conclude? So let's think about that for a second. I'm going to go back to this page and let's just think for a second. So in the first one, I broke it into tens and ones. The second time, I broke it into 2 factors and multiplied. But both times, whoops, I got this answer wrong. Both times, we got the same answer. The only time I got the answer wrong is when I added wrong. So both times we got the same answer. So if I'm getting the same answer when I do that, then what happens? No matter which way I break it apart, I get the same answer. So both models got the same answer. Really having a hard time focusing again. Sorry, guys. To find the product of 10 and 33, which is the easier computation? 10 times 11 plus 10 times 11 plus 10 times 11, or 10 times 30 plus 10 times 30? I don't think there's a right or wrong answer. But for me, doing less math is always easiest. So instead of taking 110, 110, and 110, it is a lot easier for me to do 10 times 10 is 300 plus 30, which is 330. So, and the reason is I can use 3 times 1, and what I know from place value about place value lets me add zeros mentally. So for me, obviously, the one that is easiest is this one. All right, let's make some connections now. You can draw a simple diagram to model and break apart factors to find a product. Find 15 multiplied by 24. So if this one's 20, this has to be 4. And if this is 10, this needs to be 15. Okay. Ready? It wants us to take and write the product of each of the smaller rectangles. Well, two tens times 10. 10 times 20. 200. 10 times 4. 10 times 4 ones. 40. 5 times 20. 5 times 2 tens. 100. 5 times 4. 20. So then you're going to take those and add to find the product of the whole model. So you're going to take 200 plus 40 plus 100 plus 20. I'm going to add my hundreds first. 200 and 100 is 300, plus 40 is 340, plus 20 is 360. So 15 times 24 equals 360. The model shows 4 parts. Each part represents a partial product. The partial products are 200, 40, 100, and 20. Okay, time to turn the page. Whoops. Let's do it right on the blocks. So this is the share and show. We're going to do the first 2 together. And then I want you to pause. And I want you to try 3, 4, 5, 6, and 7 on your own. Okay? Here we go. 16 times 19. Well, they've done a lot of the work for us, which I wish they wouldn't do. 10 times 10 is 100. 10 times 9 is 90. 10 times 6 is 60. 9 times 6 is 54. So now we just have to add them. Well, this is 114 plus 100. You know what? Nope, Miss Kent is going to pull out her trusty lined paper, one I used earlier, and I'm going to write 100, 90, 60, and 54. And I'm going to add it so I don't make any mistakes. So there's 4, there's 11, that's 20, 304. Did I get that right? Looks right. Yep, it would be right. Double check that math one more time. Okay. This one we get to fill in, so let's do it. They broke it apart for us. They gave us 20 and 6. That's this. 10 and 18. That's this. So let's do 20 times 10. Well, we know that 2 times 1, and then we have to add how many zeros? 2. 6 times 10, 60. 20 times 8, well, 2 times 8 is 16, and add a 0. And then we have 6 times 8. I said that backwards. 8 times 6, 48. Okay, I filled in my squares. Now what do I need to do? You guessed it. It's time to add. Here we go. 200, 160, 60. Whoops. Started writing an 8. How about 4? 48. Add them together on my trusty paper. 8, 10, 16. What did I mess up? Oh, I didn't. 16, I did carry it. 1, 2, 3, 4. 468. Okay, your turn to pause. Try the next few on your own. When you get down here, you're going to have to draw your block array. If you get stuck, go ahead and unpause and come back, and I will be working through the problems right here. Welcome back. Did you get stuck? That's okay. It happens to the best of us. Let's keep moving. We've got 39 times 27. So 20 times 30 is 600. 30 times 7 is 210. 20 times 9, 180. 7 times 9, 63. And then once again, pull out my paper. 600, 210, 180, and 63. Add them together. 3, 15, 6, 7, 8, 9, 10. 1,053. Okay, next problem. Draw and model to represent the product, then record the product. I'm going to draw myself a lovely block array. And I'm going to think 14, 10 plus 4. 16, 10 plus 6. And mine may not be proportionate, but it gives the same idea. So 10 times 10, 100. 10 times 4, 40. 10 times 6, 60. 6 times 4, 24. Well, 60 and 40 is 100. 100 plus 100 is 200. 224. Next problem. Draw myself another block. Oops. 23, 25. 20 and 20. Well, 2 times 2 is 4. Add my zeros. 20 and 3, that's 6. 60. 20 and 5, 100. 20 and 3, 15. And then you have to add those again. Well, 400 plus 100 is 500. 560. Add 10, 70. Add 5, 75. 575. Okay. Now we're down to the problem-solving applications. Explain how modeling partial products can be used to find the product of greater numbers. Okay, now we did this about 2 weeks ago because we were doing partial products. They weren't this big, but it works the same way. So basically you can use mental math to find partial products and then add the products together. Emma bought 16 packages of rolls for a party. There were 12 rolls in each package. After the party, there were 8 rolls left over. How many rolls were eaten? Explain. So first off, we've got to make ourselves a problem. So we're going to take 16 and 12. So I'm going to draw myself on my paper a block array for 16 and 12. 16, 12. That's 100, that's 60, that's 20, and that's 12. So 160, 180, 192. So we had 192 rolls. Now she has 8 left over. Remember, it says after the party there were 8 rolls left over. How many rolls were eaten? So we're going to do some subtraction. So first we need to regroup. So he takes from the 9, make it an 8, give it to the 2, make it a 12. 12 minus 8 is a 4, 8, 1. So how many rolls were left? So there were 184 rolls. 184 rolls. But that's the answer. It also asks us to explain. And let me tell you, if you have a problem like this, yes, this is part of the answer, but this is a very limited part of the answer. The big part of the answer is this explain. This tells me if you understand what you did, or if you just used a calculator. So here we go. First off, you're going to, I multiplied 16 and 12 to get 192. Then I subtracted 8 to get 100. I can write it right here, 184. All right, turn the page. Whoops. Jamal and Kim used different ways to solve 12 and 15 by using partial products. Whose answer makes sense? Whose answer is nonsense? Explain your reasoning. So first off, we got to look at both of their problems and see. So let's just think. If I had 12 and 15, what am I going to add? Well, I'm going to do 10 and 5, 10 and 2. They both did that part. Okay, so let's do the next part. 100, 50, 20, 10. 150, 20, 10. They both got that part right. Now let's add it. 100 plus 20 plus 10. What did he forget? Yep, he forgot the 50. So Jamal answer is nonsense. He forgot to add the product of 10 times 5. So you guys know, students are really good at putting this together, and it's the adding part that they forget one, and then their whole answer is wrong, just like Jamal. So please make sure you're being very careful. Let's check Kim's. So Kim took 120 and made it 120, and she took the 50 and the 10 and made it 60. So 120 and 60 equals 180. So Kim's answer makes sense. She added 2 products. Whoops, not the 2 products. And then added sums. Okay, down here. A, for the answer that is nonsense, write the answer that makes sense. So you should have done 100 plus 20 plus 10 plus 50 equals 180. Look at Kim's method. Can you think of another way Kim could have used the model to find the product? Explain. Kim could have, let's think about it. She added this way. So what if we add this way? So it could have added 150 and 30 together. Nine. Look at the model in 8B. That's this one. How would a partial product change if the product was 22 and 15? Explain why you think the product changes. So they want you to take this and make it a 2. So if we did that, this would become 200. This would become 100. So it changes the product by 150. So let's see, how can we write this? The partial product 150 would become 200 and 100. Go ahead and turn the page. And that puts us at your homework page. So today I want you to use your partial product skills. When you go into the Google Slides, on each slide you're going to see one of these rectangles and you're going to have to put the partial products in each square and give me the answer. So yes, I'm looking for you to draw the models on your homework today. So please do that. I'm going to let you stop the video now and you can get to work. Don't forget to turn in your homework.